Hi everyone, today I'm going to give you an introduction to the identification of a white powder lab experiment. This is an experiment which you will do individually, and it's going to take 2 weeks to complete this experiment. In this experiment you're going to be given an unknown white powder, which by the way is a weak acid, and you need to write down the vial number that's associated with this weak acid. Without that vial number, we can't tell you if you've come up with the correct answer, and we can't give you a grade. So make sure you write that down. That should be the first thing. Okay. So knowing that your white powder is a weak acid, and given that we've just done a titration to standardize some sodium hydroxide, we can use a titration with that standardized sodium hydroxide to come up with the identity of our weak acid. Okay. So essentially what you're going to do is perform a titration where we're not using an indicator, instead we're using a pH meter. So here's our little setup. We'll put everything on a stir plate, a stir bar in our beaker, put our weak acid in here, there's some weak acid, our pH electrode, and we'll have a burette set up above this with our strong base sodium hydroxide. All right, we can turn on our stir plate, and now we're mixing our solution, which means that we're going to get proper mixing when we add our sodium hydroxide, so we can measure our pH relatively quickly after each addition of strong base. Because we're using a pH meter, we can actually generate a titration curve where we're going to have pH on our y-axis and volume of hydroxide added on our x-axis. Now if we had a weak acid that was monoprotic, we may end up with a titration curve that looks something like this. There are 4 important points along this titration curve that you should be aware of how to calculate the pH of. Now, excuse me. Now there is a separate video on Carmen on calculating the pH at each point along this titration curve. So the first point is before any base has been added. Well, you can know the pH there. That's a certain type of calculation. The next point is in the buffer region. Okay, that's after base has been added, but before we get to the equivalence point. The third point then is the equivalence point. And then the fourth type of calculation is anything beyond the equivalence point. Okay. So take a look at that separate video and make sure you're able to work on those calculations. So like I said, this is a 2-week lab. In week 1, you're going to make sure that you are performing your method correctly. So we're going to verify the method. And in doing so, we're going to titrate a known diprotic acid. Okay. When researchers are performing an experiment that they haven't done for the first time, often they'll work with something where the results have already been published. Okay? And they can then check their method to make sure that what they're doing is correct and agrees with other findings. So that's essentially what we're doing here in week 1. We're going to give you a diprotic acid. You're going to know the identity of that. You're going to titrate it. And because it's diprotic, you should end up with something that has 2 equivalence points. Okay? Sometimes for the diprotic acids, the 2 equivalence points are not very visible. Now, you'll see in your textbook a diprotic titration curve, and each equivalence point is perfectly visible. You may not get that with every type of diprotic weak acid. Okay? So that's why we're sort of verifying our method. So here's our titration curve for our diprotic acid. Okay? The way you're going to verify that your method works is by determining the pKa's for each equivalence point, determining the equivalent weight and the molecular weight for your weak acid. And those should match up with what you know for that specific acid. So you need to do 1 titration that looks really good for this acid, And once you've verified that it matches with what we tell you it should match with, then you can move on. If your results don't match what is expected for that diprotic acid, then you're going to need to redo the experiment until you get the correct results. Okay? In that case, there's likely something wrong with your method. Or it could be the calculations. And we can talk about those later. Okay, so week 1, titrate a known diprotic acid. That means in week 2, you're going to work on your unknown. Okay? And we want you to have at least 2 good titrations for your unknown. And what does that mean to have a good titration? Basically, what we're looking for is that you have lots of points around the endpoint for your titration, and that between the 2 titration curves, the equivalence points are approximately the same, and your calculations give you very similar results. If they're drastic results, we need you to do another titration to make sure to help you verify which results were the correct ones. Okay. When you're doing your known diprotic and for your unknown, oftentimes we'll get the question, how much acid, or how much base do I add, and what kind of increments? I would say at first you need to go every 0.5 milliliters until you start to see more of a change in pH as you add that base. In that case, slow down, maybe 0.2 or 0.1 milliliters of base at a time. You really want to get a lot of points around each equivalence point for your titration. It can be challenging to do, which is why we do repeat measurements. And then how far out, to what pH do we take this? If you go to pH 11 at the end, then you've gone far enough. Okay, we're not going to be able to see any more equivalence points past pH 11. So for week 1, you're going to verify your method, and week 2, you're going to perform accurate titrations on your unknown.